My name is Dominik Bucher. I'm from Switzerland, a PhD student at the ETH of Zurich. I had been at ICT for us last year already. I came here to present our app GoEco, which looks at people's individual mobility behavior and tries to improve that, tries to make them more sustainable. The idea for the GoEco project came from the fact that everyone nowadays has a smartphone all the time, and the algorithms to automatically identify the modes of transport are getting better and better. So finally, we can use this information to passively record someone and then use this information to make people more sustainable, give them helpful feedback on their mobility choices, and just make their transport behavior improve. So the app has two components. On one side, there is this tracking, which automatically identifies where you go, which mode of transport you use. And then on the other side, there's this whole gamification component, which is comparable to fitness tracker apps that people use quite frequently nowadays. What this features is individual goal setting. So people tell the app, I want to reduce the kilometers traveled by car by a certain amount. And then it keeps track of those and helps people achieving this goal by giving them challenges, badges, leaderboard where they can compare themselves, and things like that. The project stages, because this is a research project, we had to kind of get some boundaries right. In the beginning, we have a tracking phase where we simply collect baseline data. This will allow us to make a comparison later on, so we can compare how people changed. In the second phase, we give them this gamified app, which is supposed to help them changing their behavior. And using the baseline data, we can make a comparison between the two. And then finally, it's always interesting to see if we manage to change people's habits. So meaning a year later, are they still gonna have this improved mobility behavior, or did they fall back to their old behavior? And that's why we have a third phase where we're again just tracking them so we can look at the differences, but a year later. People working on this project, there are approximately 10, but it's a on and off. Some people work 20% on the project. I work something like 80% on a project, depending a bit on if a study phase is running or if we're in between. But it's actually quite a large and diverse team. So we have people from computer science, artificial intelligence, geography. We have other people from social sciences, design as well, people who program the app. So it's quite a diverse team, and I think that's very nice for a research project as well, being so interdisciplinary. The quality of the product was mostly motivated by this living lab approach which we use, which means that we don't want people to be in an experimental setting. So instead they should be in their daily life, just performing their normal activities, but at the same time use our app which is made for research. So this is kind of a bit difficult because we don't have this experimental setting. We have to provide the same quality of app that other apps are nowadays, and people are used to quite high quality apps. That's partly why we have this design group involved as well, and why we have dedicated programmers who just work on the app so that it looks polished in the end and that the design somehow fits. That's because of this living lab approach. The group was initially formed from a consortium of different universities, which were kind of in this consortium in order to create projects like GoEco. So people there sat together, they knew each other, they knew they had this idea for a project, and then it was all about just finding the right people who would fit into the project. So this whole group of universities started as part of the energy strategy in Switzerland, where the government is putting resources and funds into this consortia in order to get projects like GoEco out of it. So that's how the people originally met, and then it was just a matter of picking the right groups. The project is scheduled to last for 3 years. During these 3 years, we will perform these 3 tracking periods. What happens afterwards is not quite clear yet. We're thinking of a follow-up project, but that depends a bit on what effects we can measure if people are actually changing their behavior. Depending on that, there might either be a company coming out of this or another research project following. Gamification elements in the app include this personal goal setting, primarily, because mobility is something very individual and people have different backgrounds and different possibilities to choose their mobility. We have this very individual goals. What we then do once the person has chosen his or her goal, we provide assistance in reaching that goal. So we have challenges, which could, for example, be something like you're not allowed to take the car on the weekend to go anywhere. So the person knows, well, if I want to go somewhere this weekend, I have to take a bike or public transport. So these smaller challenges help splitting up the big goal, which is usually on a weekly or 2-week basis. And then these challenges also get rewarded by badges. So we give people these badges, which you can have at different levels and which you can compare with your friends. So the social aspect of gamification in our app is a leaderboard that shows you in comparison with people who have a similar mobility background. So because we know from the baseline data how the possibilities are for an individual person, we can compare them in groups of people with similar mobility backgrounds. So we have these elements: goals, challenges, badges, and the leaderboard. What we found out so far in terms of transport patterns, we did a comparison with the Swiss mobility census data, and our study sample, it shows minor differences to that. We found out, for example, that they use trains a lot more than the average in Switzerland. We also found out that they travel a bit less than the average in Switzerland. Both these effects might be because most of our study participants are from Zurich and then the southern part of Switzerland. Especially Zurich is a part where a lot of people travel by train and where they don't travel that far because they're already in the city, so they don't need to travel large distances. So we found a bit of a difference to what we expected, but it's all in acceptable ranges, actually. The participants didn't get their reports back as for now. They will receive them in the next 2 weeks, probably. So we're just the last steps of finishing them. We're really interested in seeing the reactions. We're expecting quite some feedback from people, because a lot of them, they have been waiting for these reports. That's one of the main reasons they're in the project. They're interested in learning about their own mobility behavior. They're interested in how they can improve it. And now we'll see. Some of them, they might tell us that we're completely wrong. Hopefully, most of them will say that that's reasonable what we suggest and what we recorded. So when we get the data from the Moves fitness tracker, we first of all, we do a map matching with the underlying street network and also public transport timetables in order to figure out which mode of transport a person used. But then we use these same routes because the route is always going from A to B. And we feed this A to B in a route planner, something like Google Maps, which then tells us all the different possibilities to do this travel. So for example, a person could use a bike or public transport or a car, or there might be even weirder combinations or modes of transport. And then for each route, we look at the energy this route takes and we make a recommendation to the user. So basically just telling him about the least energy using alternative, and that's what the user gets suggested then. Yeah. They get this on 2 levels. So they get the in general recommendation, which is just for their overall travel behavior. But we identify routes which are taken on a regular basis. So for example, someone always goes to work every day. And for this individual route, we will actually give the recommendation on this specific route. So we see that you go to work by car 80% of the times. Why don't you increase that to going to work by bike 40% or 60% of times? The app builds on the Move's activity tracker, which might be known, but a lot of people, they use similar other activity trackers like iPhone Health, I think there's one. And what this does is it passively tracks the number of steps someone takes, but also the routes and the modes of transport where someone travels. Because the data from Moves is not 100% accurate, there's always mistakes and classification. Users are asked to validate their trips every day. So what you get basically in the evening is a list of trips you took during the day. And for each trip, you quickly have to tell if the identified mode of transport was correct or not. And the longer you use the app, the more it learns your behavior. So whilst in the beginning it's very important to validate your trips, it gets less and less important as time goes by. This is because we use some machine learning, which just identifies points of interest you've spent a lot of time, and then also the modes of travel used in between. And using that, we can improve the predictions. So in a later stage, when using the app, you won't have to validate every trip anymore. So on average, I think at least in Switzerland, people travel about 300 kilometers per week. Now, for our ideal user, which is a person who has a large possibility for change, we found out that about 75% of these 300 kilometers are traveled by car, and usually we're able to bring that down to about 50%. So depending on what other means of transport the user switches to, that's a 25% reduction of driving a car. Now, if you have 300 kilometers in total, that's 75 kilometers that we can potentially reduce per week. So with car driving. And if you look at numbers, I think driving with a car per 100 kilometers is about 10 kilowatt hours or something like that. So weekly per user, we can hopefully have energy savings of about 10 kilowatt hours. But that might be a bit of an ideal case. We'll have to see once we have to complete data analyze. The vision for GoEco is definitely to go global. That was the idea of the project originally, and I think still is, that we have an app that works across the whole world, is able to motivate people, to make people have fun, while it's changing their behavior to be more sustainable. What we have to figure out now is, of course, the whole mechanics, how to keep people engaged, how to keep them having fun. I think that's the biggest issue we're facing now. But we'll see in the project phase this fall how well we can handle that. And if it works well, then sure, we're going to deploy it in other cities as well, other countries, see how it goes there. So GoEco is programmed mostly in JavaScript. But in the backend, we have some things in Java, Scala, which is kind of Java dialect. Some things are written in Python. Because there are so many people involved in the project and everyone brings their own set of skills, it's a very diverse project in the end. But it works quite well. We have all these services connected via the internet. Once the app is finished, it's indeed, we're wanting to publish it as open source because it is a research project. I think that was in the original research proposal as well, that this should be made available to the public. I guess it also depends a bit on how this next phase is going to go. If it's, or how successful it is, how useful this will be for other people to work on as well, to use in their projects maybe. But originally, the idea was to go open source as well.